Okay, so nobody actually viewing on this thing right now. I'm gonna pivot. This will be recorded. So you can look at it later. So I'm gonna pivot over to Discord for the voice channel and try to turn that on. Hey, anybody on the voice channel listening in on this right now on Discord? I'm gonna drop a little chat over here. Okay, we got 2 viewers. Sorry for the weird glasses thing. Not a lot of ways around that, but okay. So I got 2 people viewing right now, and for you guys, since we're just doing this as a new experiment, can you jump over onto if either of you are on Discord, jump over there and just kind of let me know if you can hear this. And so what I'm actually going to try to do is mute myself on Discord. And I also need to figure that part out as well. I need to, anyway, we got to debug this thing for a couple minutes. Then we'll know what we're doing next time. Hang on a second. Okay. Okay, so so for those of you on right now, you should be able to hear me on the YouTube live. Let's see. Okay, so I got 4 people on the viewing thing. So the key here is ways to communicate to me what it is you want me to talk about relative to to what it is we're going to do relative to help section. Okay, I'm also going to do got chat window on the live box. Okay, all right. So I got 1 confirmation back on Discord that you can hear me. What I don't want to do is have the mic on Discord and then the mic's going to go here, and then if anybody's on both. What I'd also like to do, so whoever wants to drop, throw a question out, we can either go chat mode right here. There should be group chat if you're watching this. There's also chat on Discord. And anyway, I just need to know what it is you want me to go into. Okay. Cool. All right. So I got Delia. I'm not sure who BMJ is, but do you guys want to try? Okay. So for you guys that are on Discord, can I just do like a live check? Let me just make sure we're unmuted. I just need somebody on Discord to talk. Oh, hey, Brinn. Okay. So can I get Brinn or Delia or somebody on Discord, which right now that's a chunk of it. Can I get one of you guys to just say words so we can test if the sound's coming my way? And what I think I'm going to do is actually move. I got 2 monitors here. Is leave the YouTube Live Google Hangout factor staring straight at me, and then just do the Discord thing over here on the side. Okay, I need some I got some feedback from you guys from Brinn and Delia. Say words. Somebody say words. I'm not hearing anybody from. Okay, Brinn, make the attempt, please. I'm waiting. So Brinn, if you're talking, I'm not hearing it. You do have to unmute your, you have to unmute your mic. And let me try this too. All right. I'm going to do one other thing here. So sorry for the debugging time. This will be super smooth, next time, conceptually. Okay, what I'm going to do right now is live just a second, and then just try to see if I can unmute here over on.
Can you hear me?
Yeah. So then here's the last test, I think. Who was that? Was that Isaac? Isaac, can you say something else? I just need to do like a sound check.
Yeah.
Okay. Then the next burning question is, I'm muted on Discord. I am live mic on YouTube Live, Google Hangout.
Saying something else.
Okay, thank you. Can everybody hear Isaac
like
coming back through
delay.
10 second, really? Wow. So, I mean, yeah, well, I guess it makes some sense, right? Because networks. Okay. Okay, so we may have to we can try that. We may have to resort to chat for the questions or just live with the 10-second delay. Not sure. Okay, so let's do it. Let's do it this way. Ping me. I've got the chat going on. I got chat going, although it seems like the chat is on Discord. Yeah, I need you guys to get the chat off general and get over to UVU CS 2810 for the chat. Okay, get off general when you're on Discord. Okay. All right. Yeah. Okay. So here's what I'm going to do. I think we're kind of settled on this. What I'm going to do is leave myself muted on Discord, and then I don't think. I'm okay. Okay. So I'm muted on Discord, but that way you can say things this way. It might be good to ping me either on the chat on Discord or on the YouTube Live. There should be, can somebody just give me something on the group chat? All right. I said it, but I want to type it in case somebody, for whatever reason, can't hear me. And then can somebody just do something in the group chat on YouTube Live? And then here's the thing: as we do this experiment, one possibility, if the delay is just over Google, through Discord and then back through YouTube Live and then back out with too great a delay, we can either have you guys just chat me something, wait till you're ready, and then ask your question and just incur the delay. Or just simply do it on chat, and then I can just try to explain it. The other thing I'm kind of looking at here, I've got 6 viewers. Yeah, we got 6 viewers on the YouTube Live Google Hangout thing. I'm okay with that. In part because we're going to take this thing and it'll be visible on my YouTube channel. So anybody who couldn't make it can still sort of tune in and get whatever we do next. Okay. Also, I apologize that the lighting's not super great, but okay. Can I get a chat? Can I get somebody to chat on the YouTube Live, please? Just give me a text. Sorry, just a test thing on the group chat on the YouTube Live that you're watching it. Please, I beg you. Okay, Brinn. I did not see it. I've got this group, the group chat that's over on the right-hand side, and I've got 2 that I sent, and there are no others that I see from anybody else. So we gotta have some mechanism for doing this. We can continue to kind of play with this. Maybe we should. Anyway, I just want to make sure I've got a channel for hearing what you guys are going to throw out. You want to try it again, Brinn? Okay, so Delia and Brinn are saying they saw, gosh, Hershey technology. Do you see my chats, you guys? Where I said, can you guys hear me okay? Can someone add something here to the group chat? Did you see my things there? Okay, the other fallback is we use Discord for our chat. Oh, you can't see mine. Okay, so I'm wondering if it's, okay, here's the deal. Okay, so yeah, so Brinn sees the other students, but not mine. I see only me. Nobody sees mine. Yeah, anyway, I've got a column right here. It's right there. Wow. So dumb. So dumb. Okay, let me do one other quick thing. Try one other thing. Apologize for those of you that are watching this later, right? You can just kind of skip past this stuff. Okay, let me see. I'm just going to try to jump over. Just looking for the link. Okay, all right, so here's what's going on. I see the chat. Hang on a second. Link. Okay. All right. So here's what's going on. Okay. So here's now what's going on. Hang on a second. I'm now playing. I'm actually I patched into the YouTube live as a viewer, and now I can see those chats. I can see those chats here. Wow. So crazy, you guys. Yeah. So anyway, what I did was on my screen here while I'm doing the YouTube live, there's a group chat. And let me try to get rid of that and then maybe try to bring it back. You guys. So then what I did was I just swapped my screen over to the broadcast as you view it. And I see Brinn going test through YouTube, Delia saying, hey, and Austin, etc. So, and then, no, I do not see those. Bunch of junk. Okay. Okay, here's what we need to do. Because if anybody wants to do, I think for now, just to kind of keep this thing moving, let's just do chat through Discord, and then for anybody else watching this later, I'll repeat whatever the chat says as it's relevant, okay? So the next question then is, so sorry for that. I'll try to debug that another time. But what do you guys want to talk about? What do you want me to talk about? Hang on a second. We got 9 viewers. It's so exciting. Okay. Sorry, I'm trying to look at just other options to see what the deal is live, but I think it's just going to be stupid. So, okay. So let's just use Discord for chat, okay? And then I'm just going to abandon over here on watching the Google thing. Okay, what do you want to talk about? Sorry for that. We'll do some more debug. I'll just throw something up, next time. The other advantage to this kind of thing is that we can do, I can do, if I've got to be out of town, I may have a thing coming up, then I can jump on and we can, broadcast lecture in class and still do, stuff. I just got to pull away, on the road or something. It really opens up a lot of options if we figure this thing out. Okay. All right. So Brinn had a question, and Brinn, I did get your message earlier about that, okay? So Brinn said, I did have a question about homework for 7.7. Okay, let us break it down, shall we? And the email that Brinn sent me, and I presume, first come, first serve. So Brinn raised the question. So the question is, how do you recommend we complete question 7.7 on the homework that's due Saturday night, okay? So, and then she said, so you don't have to look it up. You wrote this program, quote, this program needs to be assembled by the LC3 assembler and run on the LC3 simulator and then close quote, as the instruction for this question. And I want to just pull up real quick. I'm just pulling it up on my thingamajiggy here. Homework 7. Yeah, okay, all right. Just making sure I knew what we were talking about. So 7.7, which is this one here, it's page 197, and it looks mirror image to me. I don't know what that looks like to you. Hopefully it's straight up. It says, basically, it's a little program, write an LC3 assembly language program that counts the number of ones and the value stored in R0, et cetera, et cetera. So what I'd like you to do, and once again, like always, I'm totally happy trying to come up with something that makes sense. If you guys, feel like there's a better way to do this thing, but my presumption was there's a number of LC3 you know, assemblers. There's the web version one that I've played around with a little bit so far. I can do like a screen grab on that or screen capture on that guy too if we wanted to look at it. It's the one, I'm going to send this link real quick on Discord. It is wchargein.github.io lc3web slash pound sign. And so what I'd kind of like maybe would be something like, you know, I think we could get by with a screenshot of that interface that shows, you know, the stuff, that shows the program, that shows the registers, that kind of thing. And that maybe work for you guys. You know, that's not a bad one, as long as it's a high enough resolution screenshot. So let me know if that makes some sense to you guys. And if that kind of answers your question, Brinn, and you know, we can also bust into number 7.7, but and by the way, I am muted on Discord. So right now the only communication to me is through that chat right there. Okay. There. That chat right there. That extra monitor. Great. What happened to my power? Okay. Brinn, is that okay? That answer the question? And is it reasonable? Do you guys like it? Is that going to work for you, or is it going to be so? I just want to have, you know, I want you to do some of these on, you know, on the LC3, and then, you know, actually run them. So it seems like that'd be the cleanest way. Sounds good to me. Wouldn't mind a little direction on how to tackle the actual question. Ha. Okay. Let's break it down. Is everybody okay with that? I mean, if anyone wants to preempt, I mean, this is the thing that's due on Saturday, so I don't mind focusing on chapter 7, you know, predominantly. So, and then I got my engineer pad. This, by the way, is the one I like. This is what I like, okay? But I got this standing by for writing and showing. Josh. Oh, Josh posted a link to another LC3 simulator, and Josh, if you wouldn't mind just dumping, this is on Discord, okay? And if you wouldn't mind just dropping any, you know, any comments you've got about it, like, you know, if you really like it, if you tried the other one, that would really be great, because I don't really care what you use, as long as you're, you know, kind of having that experience and it works for you. Somebody mentioned in one of the sections that they really dislike, you know, installing junk on their machine. And I am the same way. If I can do something like this, unless I'm going to be a professional LC3 programmer, none of us are going to be, then I would really rather jump on the web, you know. Same thing if I want to cut a little Python code, and, you know, I'd rather go get on, you know, whatever, somebody's that's got an interpreter. So if you wouldn't mind, Josh, throwing that on there. Then let's talk about 7.7, which Brinn asked about. Here's what it says. And if you've got your book, again, this is page 191. Write an LC3 assembly language program. I think we got that part. That counts the number of ones in the value stored in R0 and stores the value into R1. So what that's doing, what that's basically asking you for, is you've got R0, some register, right? It's R0, not just some, but it's 16 bits. And anywhere between 0 and 16 of those bits are going to be ones, right? And up to between 0 and 16 are going to be zeros. It's asking you to count the number of ones. So let's just start with the basic idea, basic premise. And I want to make sure, and I wish we had more of a fluid thing going on here. But I want to just start with the question. Is that clear? And was that already clear as to what the question was even asking? Let's kind of start with that, okay? So if I can get all right. Okay, yeah, so Josh just posted a couple of screenshots and of the simulator that he posted that he kind of recommended. So I appreciate that. So I need to know if everybody's okay with the basic premise of that question, that you're counting the number of ones and you're going to have a value. The answer is going to be, between 0 and 16, because that's how many bits you've got. You got 16 bits. Anywhere from 0 to 16 of those bits are going to be ones. And so can I get some feedback here? I got Brinn and Delia typing. Then it gives us this example. Okay, I'll see if I hold it up here. This looks weird, I get it, but it holds this guy up. And so I can actually read it. I'm reading underneath the book, okay, like this. But so if that thing contains, that number, 0001, etc. If you look at that, it's got 3, 4, 5, it's got 6 ones, right on? Then when you're done running the program, R1 is going to be that value, which is the number 6. Everyone got that? That's the premise, okay? All right, so Brent says it makes sense, but the question makes sense. How do you do it? So again, I really wish this was much more interactive. I can also try, do I dare try to run the risk of the delay? And I'm going to try it. I just unmuted the audio coming from Discord. So the problem is that it's not as interactive as I'd like it to be, because what I'm going to do, obviously, what I'd rather do is have you guys kind of kick in and engage, right? So as opposed to tuning in order to find out how to do the homework. So burning questions, how are you going to do it? What's the basic approach? How do you approach it? We already have the notion that that I'm counting the number of ones that are in R0. So R0 is being used, and that's our target, okay? And I'm going to stick the result into R1. So we start with a presumption that there's a value in R0, and I don't think our program really needs to do anything more than that. When we go to run it, we would just stuff a value into R0, just stuff the register, because it's sort of assuming that there's a value in R0. If you wanted to do tests, you could do that and I think I would just recommend using the interface and just putting a value into R0, which you can manually write something in there. Okay, and then R1. What else are you gonna do? First thing you should do. This is killing me. I really prefer this interactive. Really, really. The first thing you got to do is if R1 is going to be your counter, you got to initialize that bad boy, right? You have to. And what are you going to initialize them to? Okay. Oh, sorry. You're going to initialize that guy to 0, right? You got to, because that's your count. And the default is we didn't find any. So here's the burning question. And let me kind of break this thing down again. Every one of these of these programs we do in LC3, you have to have some presumption that I can take the problem and I can break it down in such a way that at some moment there is a result stuffed into a register, and that result can have one of 3 values. What are they? They are N, Z, and P, meaning that I've got to be able to take the number in R0, which is the number I'm trying to count how many ones there are, and I need to manipulate it somehow and tell if there is, if there are ones, okay? So what I want to kind of, and I've got to basically do some kind of a manipulation so that I can take that value in there, do something with some other value, or do something else with it, okay? And have that value back in a register. It could be back in R0, it could be another register, such that the value is either going to be negative or 0 or positive, and that tells me something about the number of ones or the presence of a 1, right? Now the likelihood, is it's highly, thank you, Austin. It's highly unlikely. What was I going to say? I don't know where I was going with that because I got distracted by Austin's text or his chat. So the burning question is, and I'm going to kind of wait here. You guys get ready to type, okay? Get ready to chat on here. what are the ways that I can tell? Let's brainstorm. This is our engineering thing. We brainstorm to see what we're doing. What are ways of telling? How many different ways can you tell if some value, if there exists a 1 somewhere in a number, right? So Austin wants to know, can you AND it with a bunch of 1s and somehow use that to tell how many 1s are there that there are in the value? Yeah, I mean, that's one way, right? So what would be an example of that? You know, can you AND it with a bunch of 1s? So what would that look like? If I took, I'm just gonna do like a stupid example, okay? And one of the things I recommend when you got 16 bits and it's kind of crazy, let's just do something smaller, like, you know, let's do this. It's 6 bits and it's smaller, okay? Just right? So the question is, can I do something with this guy? The answer here is going to be 2, right? Well, how do I do it? So Brinn says, I was thinking to possibly test each value, right? Right, and that's one approach. So one approach is I can literally I could do bit masks, right? I could do a bit mask like, again, I'm not recommending like what's the right answer here. Like I could AND it with that, right? And by doing that, I'm testing whether that bit is on. Do you see it? And I didn't write it here, but I'm going to do it now. I just wrote the word AND, okay? So I can take, this is R0. Let me put that on here. R0, okay. I got R0. That's the value I'm testing. I can AND it with this guy, right? And what's going to happen when I AND this guy together? I really wish this was interactive. But that's one approach, right? Then what I could do, if I AND this guy together, I get a non-zero value. I get 1 and the rest are zeros, right? If that value was a 0 over there, I'd get 0. Did I just now tell? Did I just now tell whether this guy was a 1? And I could do that even without looping. You know, I don't know if I'm recommending that, right? But I could literally set up, if I wanted to, 16 separate bit masks. Think about it. Think about it. I could set up 16 bit masks, one, you know, with the first bit, the next bit, the next bit, the next bit, the next bit, right? I might have to grab those. They're big. They exceed the immediate value, right? The immediate 5. So one approach is I could do something like that. I might have to put all 16 of those bit masks into memory and pull them out of there to do the comparison, you know, to actually put those in another register to do the AND. But I could do it. And then what I could do after I did that AND, just check to see if he's 0 or if he's 1. So imagine that I did something like this. I did that. I got a value right here, right? Then I've got to do some kind of a check, right? And if it's 0, I branch to the check in the next one. I'm trying to do this backwards, you guys. I branch, and if he's 0, sorry. If he's 0, there was nothing there, and I just jump. Otherwise, I increment my counter right here, and then I keep going. That's a solution. It's ugly as sin, but that is a solution, okay? Let me see. What else do we have? And I want to keep going. That's not the best. I don't even know if that's the best solution. So Brinn, you know, maybe test each value. Yeah. So Brinn's kind of going down the same road, right? Start with one of the bits, next one, next one, next one, next one. You know, take a bunch of instruction. And then, so Austin was saying, so what Austin was saying, that you start, what I would do, Austin, so Austin says, if the bit mask is 0, you add that bit mask to itself to check the next bit. What I think you're going at, Delia was then kind of saying that if I start with a value, if my first bit mask, like I did, right, I tested this guy, then the next time, and I could loop this thing, I could set up a loop, right? This is my horrible backwards art, right? I can loop through this thing and go 16 times, right? I could even then set this bit here, check it, right? If the value is a 0, then I didn't have a 1 right there. If the value is 1, I did, and I increment the counter. Then I jump back to the top. You got to work. You got to work out the detailed logic yourself. Okay, right? Then what I do is if I take this value and I add it to itself, can I do that? Right? Let's say this is R2. R2 plus R2, right? You can think you can do that with an add instruction, right? It's probably going to be a 0 in the 5th bit. So I take R2, I add it to itself. What is this plus itself? It is 0, and the 1 goes, it basically just shifts the whole thing. It's just shifting that 1. See it? The 1 just starts moving. The next time I add it, it moves to here. The next time I add it, it moves to here. See where we're going? And then I just do that. I got to do that 16 times. Okay. So, I mean, that's another way. So I could do a bitmap and then just add it to itself, which is how you move it. I think that's pretty clever. And then you still got to set up the looping structure. Okay. There's another way. And do you understand too that when we start to do these things, it's not like there's, one answer or one right way to do it. That's not the case. Brinn says that makes a lot more sense. Let me just, what other ones do we have? What other possibility do we have? What do you think? What are other ways of telling? This is the ugliest thing I've drawn today. What are the other things I can do to tell if some bit, any bit, we talked about 16-bit masks. Talked about that one. We talked about set the bit over here and just, add it to itself, right? And that'll cause that bit to move every time, one further to the left. So you get your 16-bit maps, but they become part of the natural part of the iteration. What else you got? There's at least a couple other ways of trying to tell if a bit is on. What else? Any other thoughts, you guys? And I don't know if this works. This might be the most elegant as far as I don't know. And some of you are like, I got it. It works. Move on. But there's a process here. There's an exploration. Okay. Anybody want to throw another one out? Ideas? What are other ways to tell if there's a bit on? I got nothing. Radio silence. Okay. I'll just say. Here's another idea. And again, I don't even know if you can build it with this or if it makes sense. But what about this value? Let me do about 4. Okay, let's take this value right here. Okay. See that value? Or let me make it actually more clear. Well, I don't even have to do that. Is there a way to look at this value, not even doing an instruction, just write this value into a register? Okay. And just by writing it into a register, tell me if there's a particular bit that is set. Can we do it? Anybody, please. I feel so alone. Anybody? Bueller? Come on, you guys. Throw me a bone here. Somebody say something. What does that mean? What does this guy mean? Yeah, right. I mean, he's negative, right? Yeah. And so in other words, this value is a negative number. So if I do anything with this value, like, add 0 to it and put it back where it started, I can check the n, which checks to see if it's negative, which tells me that this bit, I know that bit is on because the value is negative. Now what do I do? Right? Okay, so yeah, so the comment was, I can only think of how to check if it would be 0 or positive. But I can check to see if it's negative because the leftmost bit's going to be on if that value is negative. Okay, now then the question would be, what I've got to do now, it's really very similar kind of a process. Instead of checking this bit mask, I don't even need to, I think this might be more elegant. I don't even need this bit pattern because I already have a bit pattern, except that instead of checking this guy manually by ANDing that value, I just look here, add 0 to the value, put it back where it started so that it refreshes the NZP bits. And if that bit is on, it's a negative number. So if it's non-negative, if it's negative, I increment the counter. Then what do? Actually, I think I'm going to get overflow if I do my next cool idea. What I need to do is basically shift this guy, you know, peel it off. Well, actually, you know what I could do? You know what I could do? I could AND it. Check it out. I AND it. Can you see it okay? I AND it with, you know, something like that. If I did that as an AND, it would clear this bit, right? And preserve everything else. Then I multiply the value by 2, which tacks on a 0 and shoves everything this way. And then now this guy is the last bit. You following that? You following that? So I could I could do a thing where I check this bit. If he's set, in other words, if it's negative, I increment the counter. If he's not, I don't. Then I take this value and I AND it. That preserves all of these, but clears this one. That allows me to multiply by 2 without overflow, right? Then I multiply by 2. That guy goes away. Everybody shifts over. And now again, I'm checking, is that guy positive or negative? Oh, he's positive. That means that that value is 0. And I can do all of that. In fact, Isaac has a great question. I'll ask it in a second, but I'm on a roll here. In fact, I could keep doing this until the whole value is 0, and that's when I'm done. I don't have to go 16 times. So if I started right out of the chute and it was already 0, I'd be done, right? Because the value is 0. Initialize to 0, check to see if the value is 0. So my termination of the loop could always be 0. When he's non-zero, I loop back to the top, right? Mask it, shift it, check it. I sound like a song by Daft Punk, right? Only I'm not moving fast enough. Anyway, I mask it, check it, shift it, right? And then when the whole thing is 0, I'm done. Otherwise, I jump back. I think that's brilliant. I'm proud of this, okay? Now, Isaac asked the question, and I'm going to come back to Austin's. Isaac asked, could you only look at the last 7 bits after checking the first one? And so I need to know, Isaac, what you mean by the last versus the first. If you're talking about in this system, if we're talking about the first bit, I need to understand that better. I'm not sure just what that means. So give me some clarification, okay, Isaac? Austin asked, that only works if it's a negative number though, right? And the answer is no, I don't think so, because if it's a positive number, I look at the value, I check to see if it's positive or negative, positive, negative, or 0. If it's 0, I stop completely. If it's positive, I don't increment, and then I go ahead and shift. If it's negative, I increment, clear it. Is that what you're talking about, Austin? That I only have to do this instruction here if it's negative. Yes, that's right. If it's positive, I can just add it to itself, multiply by 2 in effect, and then everything shifts. That works. All right. Okay. Yeah. Okay. And Isaac clarified. First is the leftmost bit, higher bit. Yeah. Okay. Does this help? And what I don't want, I can also, I can break this down further. I can go into, unfortunately, what I need is more of like a hand-drawn thing. Is that nice? You like that? I'll do it like this. A hand-drawn thing that I can sort of screen share with you guys, which I can screen share with Google, Hangout / YouTube Live. And this is a little cumbersome because I'm doing this action. I'm not quite sure the best way to do that. I could set up a whiteboard. I do have a whiteboard over here, but you know what I mean? Set up a whiteboard so I can get on there and do stuff. Maybe that'll work. I can do that in the future. And then I guess the question, the burning question is, you ought to, I can do screen share with Discord. Nice, thank you, Isaac. Of course, it's the gamer platform. No, the next question I guess I've got is that enough? You guys, do you, okay, I should, I could say, given that logic, can you, you should be able to break it down from there. But on the other hand, I can also say, oh, Austin, okay, only private call for screen share. I should, I can say, given everything we've talked about, that should make some sense. But on the other hand, obviously not everybody gets what to do with that next, okay? And so if it's helpful, we can break it down further and, try to work it through. It's definitely easier, on the board, just logistically. We can still kind of do this. Is that helpful, or do you want to go? Would you rather go like onto another problem to at least understand it, or do you want to try to drill down in this one? And here's the thing: the first step in any of these is really understanding what the thing's asking, and then next, kind of understanding how can I possibly break that down? What are the things that I could do to even affect a solution, right? And once I understand how I'm going to approach it, maybe algorithmically, then I got to break it down into steps. And then each of those steps have to be refined further. Like, okay, that means I have to set up this one thing, this other thing, and the other thing. Okay. Okay. Does anybody want me to try to break that down? Obviously, it takes a while. The people jumping in, chiming in right now, I think are getting it. But I know that's not everybody. So anybody want me to go deeper? And here's the other thing. I know some of you that are going to watch this later that aren't on right now are going to be like, Dr. K, go deeper. But you're not here to represent yourselves. So I'm stuck with taking the advice of the people who are here in terms of how we use the time. So we can go deeper, or we can jump to another one, you guys. Whatever you prefer is fine by me. Talk to me. And also, we can try, if you guys want to try the mic thing again with the delay, coming in off of Discord. It might be like bad echo to you when you're saying it, but to everybody else, they're not going to hear you say it. So the delay might not be as bad. I've got this still unmuted, okay? So I can hear sound coming off of Discord. Okay. So next question, if everyone's good, could we look at 7.22? I'm not sure I understand what the question's asking. Okay, so let's go to that one. I think that's totally fine, Delia. Okay. And I think there might be a word that's dropped in here, which is unfortunate, but here it is. I'm going to read underneath, okay? It says, and I'm going to try to read this thing backwards in mirror image script like Leonardo da Vinci used to do. The LC3 assembler must be able to map an instruction's mnemonic, okay? Opcode into its binary opcode. Let's start with that. Okay, a mnemonic, M-N-E-M-O-N-I-C, mnemonic is, there's probably a better official definition, but here's the gist of it. Essentially, it's just like a memory trick, what's a good example? The notes on a treble clef, every good boy does fine, right? E, G, B, D, F, and those are the notes. So that's a mnemonic. It's like a thing you can remember that's easy to remember than the thing you're trying to remember. So in the same sense, the binary opcode for the add instruction is 0001. The mnemonic is add. Everyone get that? So I apologize. I don't think he introduces the word mnemonic. I don't know. It's not in the index. That's what a mnemonic is. And maybe I need to add a clarification. Would that be helpful if I added a clarification? Hang on a second. This is called You Get to Watch Me grab a Post-it note. I think I probably need to add, and that is 7.22. I'll add a note about that to the assignment so that it won't be as confusing to everybody who doesn't know what a stinking mnemonic is, okay? So that might be, so the question is, the assembler has to map the name, right? LDI, ST, let me see. I'm gonna get, Austin just asked a question, but I wanna get to this, clarifying the thing and then get to that one. So therefore, for instance, given an add, it has to generate the binary pattern 0001. I think that's pretty clear, right? I see the text string ADD, and then I have to map that and generate 0001, right, in that location in memory. I've got to know that it does that. So write an LC3 assembly language program. Prompts the user to type in an LC3 assembly language opcode and then displays its binary opcode. Okay, now here's a question. One of the questions. Let me see, what's the end of it? Oh yeah, if the assembly language opcode is invalid, it displays an error message. What are we gonna do? Is this? Oh yeah. So Austin asked. So we need to make a program where we type in capital A, capital D, and it displays 0001, or we type in capital A, capital N, capital D, and it displays 0101, etc. Right? Correct. And then if you just type in Bob, it'll say, sorry, not a valid opcode, something like that. You can adopt any accent you feel like for that, okay? But that is correct, Austin. And then, so Delia asks, do you use the ASCII code to determine the mnemonic opcode? What do you think? Think about this. This is good. This is good. You got to think about the logic here. Let's break this thing down. Okay, ready? Anybody want this? No, I can't give it to you. Screenshot it from earlier. Okay, fresh paper. This is actually very cool, and this is the rudiments. The reason I gave you this problem is this invites you to think about the rudiments of parsing and of lexical analysis. Yes, there's a method to my madness, okay? So yeah, burning question here. Let's break it down again, okay? We gotta put on our engineering hats. Remember this thing? Do you remember this thing? See me peeking at it? I can't see the screen when I cover the camera, okay? Remember this though? Yes, you do. Well, let me ask you something. This thing is in alphabetical order right now, which is also kind of convenient. I mean, I groused earlier because I thought it should have had a better organizational thing, though. But here it actually starts to make a difference. So yeah, first of all, you've got to do the trap instruction. Okay, you got to do the trap instruction to allow the user to enter a character, use the one that, you know, they press it, you pull it in, and then you echo it, right? So they're going to do that thing. And so do you do that? You do that trap. Now, here's an interesting question, and I want to throw it out and get your typing hands ready to go here. One approach is I let them type it all, right? And then maybe I make them, you know, type it and then press enter. Okay. Well, the way my understanding of how the trap thing works, go to chapter 7. Let me see, where are we? Okay, no. Where's the darn trap stuff? I think it's in chapter 6. So I'm trying to find. You remember the one? Anybody? Where there was a bit of documentation that walked through how you. Come on, somebody help me. I know it was in there. I thought it was in one of the ones that chapters that we've hit already. Am I that evil that I've been pulling stuff from chapter 8 the whole time? I might be. Oh, Delia says might be in this appendix A. Okay. Yeah. Well, there is stuff there that shows keyboard echo, but yeah, appendix A. Let me look. Well, there was actually another table. Okay, there's a table. I'm gonna point it to you, or point you to it. Come on, guys. Maybe it's at the end of these instructions. I'm in these pages where all the mnemonic stuff is. Okay, yeah, here it is, right here. So it's table 8.2. You see it? Okay. No, I mean you got it somewhere. Table 8.2. Okay. Trap service routines, and a little bit in the lectures, which I still have to post. I still have to post chapter 7 tonight, and I'm going to fix chapter 6. The dumb mistakes. Okay. So, Tang use 543. Thank you, John. Yeah, okay, he said it, and then I have to piddle around and go find it. Yeah. So, page 543, and we've got get C, which reads a single character from the keyboard, and it's not echoed onto the console. What's the other one? In print a prompt on the screen, read a single character from the keyboard. Characters echoed onto the console monitor. So anyway, but you got to play with these ideas, and then you're going to take an input. So back to the question in 7.22. So here's my question. One approach is you let them type, and as they're typing, you allocate some space, right? You've got to allocate some space, and we have a couple of approaches to doing that. We have fill assembler directives. We have the .blkw, right? And Delia just said, I forgot about trap codes. Yeah, that's how we do any of that kind of I/O. It always has to be through some kind of trap instruction. And again, we haven't gone deep on these, but dive in. Look there again. We've also, I think the lectures have gone through some of this stuff as well. And anyway, 543. So you can let them type all the action, save it away. Now I've got a set of bytes in memory, right? So let's say, for example, that they're going to type add, and we did this, .blkw, and let's say we allocated, I don't know, 20. So we did something like that, right? We said, that's the assembler directive, .blkw 20. And that's going to give us 20 bytes. And then, there's also string input. What's the string input? Hang on. Back to page 543. There's a, where's the one? Isn't there a string input? Looking at it, we got get C, we got out, which are both involving characters. And then, no. The input's a character at a time. It always inputs a character at a time. So what we could do is, they type a letter we take that character, it comes into R0 by default. We then take that value in R0, shove it into the memory that we allocated, you know, with that. We could even call that something like, opcode or, input string or something like that. We put some label right out here on the left, okay? And then when they press a key, we do either the get C or the in. You got to look at that. In, we print a prompt and then read a single character. You got to think about the smoothness factor. I'm not sure the best way to deal with that. But those are your tools. And then as those are coming in, we can be putting them into that memory location that we defined with block W. Put the first byte, every byte's going to take a whole word. Okay. But basically it comes into R0. You just take R0, shove it in there, and then you just keep going until, when do you stop? When do you stop that operation? Well, what are the ASCII codes available to me? And again, we're just talking algorithmically. We're not talking about how do I write that code. But what are the things that they can do? Another thing you can do is experiment on the keyboard. Remember I said the documentation is always wrong? Well, it turns out, and this is a little bit of learning here, I'm looking at the ASCII table now, okay? See the ASCII table. There's a null. Somewhere here is a carriage return, okay, which is hex 0D, carriage return. There should be also a line feed, which is LF, and its value, if you can just look right there, there is, I can't read this super well backward. Line feed, carriage return, okay? So carriage return and line feed are, they go back to typewriter days, but if I press the return key, so here's one of the things I would do is write a little program, right? You're in the little debugger that just takes an input. Press the return key. What is the value generated? Okay, that's the value you can look for. Okay, so they're typing, okay? And then when they're done typing and they press return, you can just, in other words, every time they put a value in there, if it's not return, jump up and take another value and check it. Is that return? When it's return, you drop on through. Until it's return, you let them go. Now, the other thing that you've got is, maybe you're just going to say, look, the longest instruction, the longest mnemonic instruction is 4 characters. So you might just say, look, they got to type 4 characters and a return, and we're done. So that's totally fair. You don't want to get into it. You don't want to just like, we're typing indefinitely. Or you could just say, I'm allocating 10 spots, and I'm just going to assume that everybody's being well-behaved. There's nothing wrong with assuming that everybody's going to be well-behaved in this tiny little program. But you could also do it where you could say, if I ever get to like, a 5th character and it's not a return, I'm going to stop. But let's just say that we're not going to get that fancy. I assume that I'm going to type something, that's either legitimate and press enter, or I'm going to type something garbage and press enter, but that I won't do more than 4 characters. I think that's entirely reasonable, okay? So, like I'm saying, one approach is to do this thing basically by letting them do this loop, and then I'm stuffing this block W. I'm just filling in block W. Okay. Now here's the struggle: is that later on, I got to go back and actually see, is this valid, right? And there might be an easier way to do that. Again, if you have ideas and opinions, but I've got a few ideas of my own. Let me ask you this, and I'll look for some feedback from the people who are on. Would it be better? I think there's 2 approaches here. One is I take that input as a separate idea, and I'm just putting those values into memory. What I'm basically doing is building a string. Okay, that's what I'm doing. And then at the end of the string, even, I can put a 0. When they say return, I put a 0. So I got this null terminated string. Okay, not bad. But now I've got to walk through that string a step at a time to see. Well, that's sort of one approach. The other approach is that as they are entering the characters in the first place, I'm living in a world where there's no backspace. I'm living in a world where you press a key and you're committed, okay? Some stuff we've talked about, it's been a little while, but there's some stuff we've talked about conceptually that's really, really handy or something like that. Do I have any guesses? Do I have any takers? Oh, any takers? The truth is you got to probably do this either at the point of input, you got to deal with this, or you're going to have to deal with this anyway when they're all just sitting there in memory. So eventually they're going to wind up in memory, right? And then you got to start sifting through. How do you look at this thing and tell, I don't have a string compare function, right? Talk to me. What do you got, guys? So, okay, Delia said, I think I try to compare first. Do you mean, Delia, do you mean compare as it's coming in, as opposed to read them all in, put them into memory, and then you got to pull them out of memory anyway, one at a time, right? Is that where you're going with that, Delia? Because what I was thinking about was, okay, look at the table, okay? Track my process here. Yeah, as it's coming in, that's what Delia said, right? Because let's say that I'm doing that thing and I'm on the keyboard. I type Z. Am I dead already? Yeah, there's no Z. Nothing starts with Z. I press Z and you already know that's not a real instruction. Then the only decision is, do I press Z and you immediately go blah? Or do you let me finish to let me feel, let me feel something, right? Then I can just go into a zone, whatever, if I wanted to make it a little more smooth. But I could just go Z, no, right? And if I go A, am I still alive? If they type A, are they still alive? Yeah, because I got options with A. So they go A, and then they go Z, dead, okay? Or they go A, then they type an N, like still alive. And then you got another choice to make. They go D, do you say, yeah, but they were going to type Andy because they thought this was like Toy Story. And they were confused. Do you let them finish, right? So that what you would do then is, do you see where we're going here? Now, I'm gonna do something that's going to blow your mind, okay? I'm going to draw something, okay? Yes, that's what we're going to see that? That's horrible, but that's an arrow, okay? And I'm going to just call that start. And I'm going to transition to begin with to this state, all right? I am in the waiting state. I'm just going to call that waiting. Do you remember the state machine from the exam that would go, if I get a 0, I move. And if I get another 0, I go again. And if I get another 0, I go again. Thought it was just crazy. Thought I was just torturing you. I do a wait. Now, at this point, if I get an A, right? See what I'm doing here? If I get an A, I transition to this state. Okay? If I get a B, I transition to that state. What else can I get? I can get, the valid places I can go are A, B, J, just like first letters. You see why I'm doing this? L, N, R, S, T. That's how many places I can go. Okay? And then the last thing I've got, if I don't get one of these letters, that's an error. So I go to A, I go to B, blah, blah, blah. Okay? Now I'm in the state that we'll call B. I'll call that guy B and I'll call that state A. Okay? I get to B, there's only one instruction that starts with B, and it's BR. So the next thing I'm going to do, I'm going to check to see if I get an R. See where I'm going here? I'm in the B state. I just got a B. I'm going to see if I get an R. If I do, I'm in the BR state. You with me? Then I can say I get a return. And I'll be honest with you, I don't know what LC3 delivers. If I press the enter key, I'm going to try it. I'm going to write a little code. If I press the enter key, am I going to get a carriage return and a line feed? Am I going to get, what's the value? But that's the value I'm looking for, and that's what I'm calling return. In which case, I have this state, which is, I'm just going to call it the 0, 0, 0, 0 state, which means, okay, are you tracking here? At this point, while I'm waiting, I get a B, I go to this state. If I get an R, I go to this state. After they type BR and I get a return, I go to this state. And what do I do in this state? I dump to the screen 0, 0, 0, 0. Now, how am I going to do that? I'm going to do that, and I'm going to get back to finishing the state machine. But I'm going to do that because I have a compiler directive, sorry, assembler directive. Where's my assembler directives? Got to be chapter 7. Okay. String Z. String Z. So what I'm going to do with string Z is I'm just going to have a location in memory, and I'll call it, you know, maybe I'll call it something like, you know, BR opcode or BR, you know, maybe just BR. I don't know, but I'll call it something. And in BR, I'm going to have a string Z, and it's going to go character 0, not the number 0, the character 0. Where do you get that character? The ASCII table, okay? And it's going to go character 0, 0, 0, 0, and then the actual value 0, because that's the null termination. Track with me. The character 0 in the ASCII table is 30 hex. So it's going to go 30, 30, 30, 30, 0, 0. That's 4 characters of the letter Z, of the character 0, followed by the number 0, and that's a null terminated string. Okay? Then I go back to page 543. 543. You see anything here that might be useful? Like put SP, it's a trap instruction in table A.2. Write a string of ASCII characters to the console. That'd be handy. So I can set up a bunch of strings. If I get to, I hope this is making sense. This is solid gold, you know that. If I get to this state, I do that put string thing, and then I'm done. You know, or at that point, really what I do, I output, right? I output the string, and then I go back to the wait state. Okay, now, if I get to B and I don't type an R, what happens? Okay, there needs to be somewhere, you know, I'm going to put it over, it doesn't matter. I'll put it over here. I'm going to just call this the error state. It's where I just dump this generic message. I just say the same thing no matter what. So if I get the B, and then from the error state, sorry, I'm going to go to B. If I get an R, I'm in that state. If I don't get an R, so this is literally, I'm just going to put a star as like just a placeholder. Anything else, I'm in the error state. After I do the thing I do with error, I go back to the wait state. You see it? You see how complex it can get? But this is really a state machine problem. It is a state machine problem. The truth is, when I get an A, what's the next things I can get? I can get an N or I can get a D. If I get a D, I better get another D. If I get that second D, I better get a return. Any deviation from any of that path, and then you could basically just build that logic. Okay, just build that logic out. So all you're doing is saying, am I still alive? I'm jumping. If I'm not, I'm jumping, right? And you can think of it this way as a state machine. If that helps you, I think it's a really smart idea. And this is a way to kind of break the problem down. Now, here's the thing. I have a lot of radio silence over here, but I think it's maybe because I'm swinging the big stick and you're appreciating it. When you're done with this thing, if you build that whole state table again, these are all the different initial states. Okay, okay, I'm going to do it. I'm going to do one more thing. I'm going to flip this upside down. A can go to two states, D and N, right? D can go to the next state, D, and N is going to go. So here's what I'm doing. What I'm doing is going from A, I can go to D and then to D. Or I can go to N and then to D. And then I better get, you know, a return at that point, okay? So, and then I'll just do that for the sake of completion. Okay? And any other branch, any other change, I'm just jumping. So what you're going to do, there's going to be some conditions. Okay. Thank you, Brinn. Right? I get the A, then I need to get a D or an N or I'm error. And then if I got a D, I got to get another D or I'm error. And literally, there can literally just be some chunk of code that is the error code. And the error message is just a string that you allocated and that you then dump. And you jump back to the beginning. Start again, go again. Just keep inputting it. You can even go like until they press like the letter lowercase q to quit or something like that. You can do whatever you want, right? Or you can just run it, you know, one time through and that's all you do. Okay? Then, so that's A. If I do a B, then I got to have an R and then a return. And anything else that deviates from that is going to be problematic. Okay, now let's go to J. J can go to M and it can go to S. All right. From the M, I got to go to P. That sounded really wrong. I'm doing fine, really. But jump. And okay, see where I'm going, right? I'm going, J can go to M and then to P and then to return. And that's valid. Or I can go to an S. If I get a JS, the next thing has to be an R. Okay, and then here's the tricky part. After that, on J, I can get an M or an S. If I get an M, I got to get a P in return. If I get an S, I've got to have an R. After the R, I can either get a return or another R. On the second R, I got to get a return. And again, anything deviant from any of these things is a condition you're checking, and then you're jumping to that one spot. And that this is going to be a little bit, I mean, a little bit, maybe a lot of it complex. There's a bit of complexity. This is a bigger program, okay? What you're going to find, though, is that the logic of it, and you're in assembly language, so you don't have to do it the machine language, map it all up. You can set labels, right? Like you can set a label called error, and another label called, you know, BR and JMP, and, you know, you can even label things as states, like, you know, what's going on with my hair? But you can go with, you can label them anything you want, and just you're doing the checks to see, am I still alive? If I'm not, I'm jumping, you know, other stuff. Do you know how to compare something to see if it's something you expect? Yeah. And again, all those values, those letters, you can stuff those into memory and you can do those kinds of things. Okay. What's going to happen is it's going to be long, but it's going to be repetitious. Once you get the idea, you're going to be okay. 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 Then you see where I'm going. L. Okay. Let's do L. L can go to D, and it can go from D to either return I or R. Hang on, I'm just going to kind of do this thing, and then I'm going to stop. You can get the idea. You get the rest of this. Okay, so what I'm doing here is with L, I can get a D or an E. If it's an E, it better be an A and then a return. If I get a D, I can then go to return or to I or to R. These are all valid. Anything else is an error. If I go L and then a D and then an R and then the return, or LD and I and return. Anything else. So you can break this thing down. So state machine. Because really what you're trying to do is say, am I still alive or am I done? Have you already blown it or are you still going? And notice in some cases, like if I say LD and I stop, I'm okay. If I say LDI, or I can keep going and still be okay depending on what I do next. Okay? I got 16 instructions, I can also do, I can do little routine. I mean, I can get as fancy as I want on this thing. But, that hopefully helps you to think about it and kind of break it down. What number was that? 7.22. This is meaty. I grant you that this is beefy. You're going to be feeling very satisfied when you get this thing working. I got some appreciation. Okay. And again, you're going to have to write, use comments, right? Use comments. I'm working on this thing. I'm working on that thing. I'm working on that thing. Break it down. Okay. Okay. What else? We have 38 minutes before I am going to eat some of these. I would eat them now, but I don't want to make you feel bad. But I'm going to eat some of these and then go to bed. I don't know. And then there's also these. Okay, these right here, these are the bad boys. This is the way to go. I'm just telling you. I'm waiting to eat one of those, and I'm just dark chocolate almond. You know what I mean? It's the only way to go. Okay. What else? You got me. You got me till 10 o'clock. Then I think we go into Fortnite, if I remember correctly, what we decided earlier. Where else do you want me to go? By the way, I don't know how many points. I will go back and read. I don't know how many points I'm giving you for 7.22. It ought to be a crap ton, okay? I'm realizing that it needs to be an official crap ton, and I doubt it is because, again, first time through the class, right? I haven't been through all of these. Oh, here I am. I was sitting on it already. I'm a doof. Oh, I'm a double doof. You know what? I just set the 10 points. Brinn, thank you. No, I'm a doof. Also, I realized that I put this accidentally into the exams. Okay, I just changed it to be an assignment, so sorry about that. No, how many points do you think that should be? Because remember back some of the binary stuff we were doing earlier? I want on the other hand, you're like, no, don't jack this up because that's one of the ones I'm not going to do. But the truth is, you ought to get some credit for that. What do you think? I think it's got to be at least 20 points. Oh, yeah. Brinn wants exam points. Okay. Yeah, I'm making that 20. I'm making it 20. It's beefy. 7.21 just says assemble it. What does it do? You just got to figure out what it does. I think that's got to be 20 for 7.22. Plus, I just helped you along at least a little bit. 7.16 is what does it do? Yeah, these are kind of what does it do. And then 7.7, is that the one we went over already? Yeah. 7.7 is 8 points. I think that should be a little beefier as well, don't you think? I'm going to make that, I don't know. It's got to be at least 10. Let's say, yeah. Yeah, Jan's going to suffer on grading all these. Yeah. Yep. I may have to help her. We got to do this before the midterm. I'm making 7.7 12 points, okay? I think it should be 12. I just think it's beefier. again, having not done these, I apologize. I mean, I didn't immediately know how to calibrate them. 7.4 is create a symbol table. That's not that hard. Okay. All right. I think this is calibrated better. And then let me tally these up and change the point total. It's going to be 6.8. That's 20. 26.30. That's now 50. Okay. I'm saving it. When did I have that due? November 3rd. You guys going to be okay? You're going to be okay. It's a lot. I want you to just know, so that, because I know you're all feeling really sorry for yourself. I want you to feel sorry for me. Okay, and here's why. Because when I was an undergrad, in my first Saturday night, in my first assembly language class, we actually had to implement linked lists. We implemented a linked list in assembly language. And it was octal. It wasn't hex, it was octal. Every 3 bits was a value. And anyway, we did linked lists where you had to like insert a record into a linked list. This was like my second or third computer science class, in my whole career. And we're doing linked lists. I didn't even know what a linked list was. Tang says maybe Monday would be best. I mean, my philosophy, right? I don't care. And I mean, if I move to Monday, there's no sympathy for anybody who doesn't get it done, in the sense that you got more time to do it. I don't want to short the studying. Midterm review is going to be Tuesday. I don't have a problem with making it Monday. And then my recommendation to everybody is bust your royal butt on Saturday, and then you overflow to Monday, Sunday or Monday. I mean, overflow to that. Don't just say party on the weekend, Don't just say party on the weekend and then wait till Monday. You're just going to be extra doomed. Everyone's okay, no sympathy, right? I'm going to change it. I'm going to change it. Okay, let me come back to the question about, Austin. Yeah, we're really busy talking about the assignment, man. How dare you talk about the actual material that we're talking about? I'm changing it to Monday night. Okay, that's the 5th. I just changed it. Okay, I mean, I really don't have a problem. I don't know what your loads are like. I mean, other than the fact that to do your, I'm gonna have to. How do I gotta grade it. That's the downside. You got to give me more forgiveness on the grading if we don't have those all the way cooked. I'll have to pull some kind of stunt on Tuesday. Maybe Tuesday morning I can do a thing where, no, you know what I can do? If I were to Tuesday morning, maybe just not do any office hours and just go grading mode so that you've got some sense of stuff, and then come into class on Tuesday. Okay, Austin, what is a symbol table? What does it look like? Okay, we did this. You're welcome, Brinn. Okay, the symbol table in the book, this is chapter 7. Okay, Austin, so the first pass, creating the symbol table. This whole section here is about the symbol table, and then it kind of goes there to there. Okay. And what it basically does, the symbol table is just a data structure, and it's a data structure. It's not in your program. And I talked about this in class today. You're welcome to everybody thanking for the Monday push. So the symbol table is a data structure in the assembler. It's not a data structure in your program. Okay, everybody got that? And it's a data structure that just looks like this. Here's just some example. I can't see this thing, right? I want to get it close enough that you can read it. You see that? So what that's doing is after we pass, we're just finding what the labels are. And then what is the value that the label has to be equated to so we can clean everything up when we do our second pass, which is the pass where we actually generate the actual instructions, okay? And then we talked about today, and this symbol table right here is related to this program right here. And then you notice on that, this is on page 184, okay? And 184, we've got labels like test, get char or get character, output, ASCII, PTR, aka pointer. And if you look over here, right, there they are. Test, get char, output, ASCII, PTR. And these values are the values in memory that these instructions, well, you can't see, sorry, I'm such a doofus. Hang on, let me back up over here. Try to do this better. Those values are the values in memory that these instructions, like right there, the value in the symbol table, what does that say? Output. This is, you know how hard that is to read backwards, and then it's kind of faded and gray. The value in the table, it'll say output, and there'll be a value next to it. That value is the spot in memory that that instruction is going to occupy when the assembler's done with it, okay? Now, we walked through that in detail today in class, and it's in the slides for chapter 7, which I'm going to post. As soon as we're off here tonight, I'm going to post. And I'm going to do that while eating these. I am going to do that. These are going to keep me motivated to do that. For you, for me, okay? All right. Okay, what else we got? Oh, yeah, okay, thanks, Austin. Let me see. Okay, so everybody very welcome for the, I mean, they're just expressing appreciation stuff, so you are very welcome. I also realized, having done this a few times in my office, and I really don't mind it, it's just, it doesn't scale, you know what I mean, with 2 sections, and I don't know what, I've got 65 students or whatever. I can't do a half an hour, you know, a week with everybody. But if I can hit common things that everybody's going through in this setting, then it makes a much more efficient help section. So, okay, so Brinn, another question after Austin's. Okay, the .ORIG X3000, okay? Everybody know what we're talking about? It's like, hang on, like that guy right there. .ORIG X3000, okay? That guy, by the way, I'm going to work on this whole thing and try to make this a better arrangement so we can get a much more interactive, you know, more like a webinar kind of a feel, and I'll work on it. I've got some ideas, but technology keeps getting better, and, you know. Okay, so Brinn asks, that .ORIG X3000 isn't an actual instruction, correct? By which I mean it is not an assembly language instruction. It's not something that winds up in your program. All the dots are instructions to the assembler. Remember, we talked about in one of the sections today that the assembler has this high-level view of things. It's kind of directing traffic, you know, you over there, go there, you go there. The assembler's doing that, it's high level. It's not the traffic, like I'm thinking about a traffic cop, like after a football game, right? It's not the traffic, it's the cop. Good one? That is a good one. I'm always trying to find the right metaphor, right? But so the assembler is the traffic cop, not the traffic, okay? So it goes .ORIG 3000. Assembler just goes, oh, you want me to start the program loading at location 3000? Okay, all right, we good? So Brinn asks, is it just helpful for the engineer, and is it a comment? No, and I mean, no and no. It is, sorry, Brinn, 2 strikes. It is, number one, it is It is, what is it? It's an instruction from the engineer to the assembler of where to put the stuff. Okay? I am telling the assembler that this is where I want you to put these instructions in memory. So it's not a comment, because comments are purely ignored. They're just for the engineer's memory, little institutional memory. It's not a comment, and it's not so, but it is informational to the engineer, because the engineer looks at it in the sense that everything the engineer writes is informational to the engineer, because it's what the code actually is, right? Cool. Okay, I got a big, really ugly, blocky, yellow thumbs up from Brinn. Okay, thank you, Brinn. Okay, 24 more minutes. What else you got? And it's okay if you're done. I know you guys, as college students, I know that you're usually, in bed by now. And so I want to drag you up too late and get you cranky. I, as an old man, I'm pretty much all-nighters every night. You know what I mean? If it wasn't for faculty meeting, I wouldn't get any sleep. You know what I'm saying? So what do you got? What do you got for me? We did a lot of chapter 7. We can back up to chapter 6 too. Because here's the thing too, that I know that a lot of, based on the comments today in class, in both the sections, that there's definitely confusion in some of the foundational material. And this is also meant to be remedial for anybody who's struggling, with any of the stuff from chapter 5 or 6 as well. Oh, you know what? I need something more powerful than this right now, and I'm not going to get it. Well, I will get it in 23 minutes. Okay. I've also got, while I'm waiting, anybody, what do you got? I've also got, oh yeah. Don't think ill of me. Okay? Don't judge me. Don't judge me. This is a judge-free zone. Okay? These guys right here, I tried them for the first time. Dove, no offense, but not my favorite chocolate brand. Okay? Not my favorite chocolate brand. Brookside. These guys have cinnamon. You should try them. For some of you, it's the ticket. What else you got? Brinn says she's good so far. Oh, Marabou. I don't know Marabou. For chocolate, thank you, Casual Gamer 16. I don't know who you are. Anyway, so Brinn said her questions are answered. Anybody else? I blocked the time out. Anybody else with any other questions that I want to, that you'd like me to get after? Maybe the other thing I can do, I'll try to do, is maybe in the comments or in the description for this video when it goes on to YouTube, maybe I'll try. I don't want to make. Actually, if somebody wouldn't mind a little extra credit, not at the expense of the assignment, is prepare some description notes for, if you would, that basically just goes at this time, homework 7. Such and such. I mean, I can do it. If I'm not doing this, then I'm going to be doing other things to help you. But if somebody could, like, for extra credit, maybe just make just volunteer to kind of go through it and just give me time. You know how these work, right? You just give me a time and what's going on at that point. So somebody else can come in and jump. They don't need to watch the 2 hours. They can jump to the part where I'm talking about, homework assignment 7.22 or something like that. Okay. All right. So if somebody wouldn't mind offering to maybe go through and look at, just give me those start points so we can put them in the description. Okay. So Tang wants to know, can I talk a little bit more about .blkw? And yes. Why, yes, Tang, I can. Okay. Let me see. Oh, is anybody else hammered besides me? because I know I am. I'm looking for those compiler directives. Wait, Tang, were those? That wasn't that 543, was it? No, those were the trap instructions. Where are they, you guys? Where's the instructions? Somebody throw me a bone here about where the assembler directives are. 182. Thank you, Tang. Oh man, I'm sitting over here 3 pages away. I need a PC offset with a value of +3. Thank you. Okay. Page 182. It's this stuff, and he is asking about that guy. .blkw. Okay. So .blkw, and I don't know what we call this, block of words, block W. We need a shorthand. Okay. And then Tang, you know, I'm kind of doing this for you. I mean, I'm doing it for everybody. I'm just saying in response to you. So if I'm not nailing it, you got to keep egging me on here, okay? But what it says, this is going to be nighttime story time with Dr. K. So block W tells the assembler to set aside some number of memory locations, okay? In other words, a block of words. And then, you know, the actual number is this is the part where the language gets dense. The actual number is the operand of the block W pseudo op. Okay, what that means is, I'm trying to find one here, hang on. Dot BLKW. And, oh, here we go. Okay, so I'm jumping over to page 179, and this is what we actually did in class, right? But the idea here is, if you look right here, can we see it? Can we see it together? Right there. Number BLKW1. What that does, that again, all the ones that start with dots and then they're all caps, those are assembler directives. Okay? Those are assembler directives. That block, BLKW block word, it says, first of all, that's just a label. A label doesn't even have to be there, but we put a label on it because we want it. We're going to use it. And that just says, allocate me 1 word of space. So earlier when we were talking about something where I'm going to input characters from the keyboard, and maybe I'm going to say you get to enter 10 characters, I would go, you know, whatever, you know, keyboard input or something. And then I would just go .blkw and then 10. That's it. It just tells you how many words to allocate to that space. And it does not initialize them, okay? It doesn't, it is whatever they just happen to be. It says you've got it, they're yours, and they're not assumed to be any value. Okay, if you want those cleared, you better get a 0. You better get a register. You better clear that register. You better stuff the value of that register using a store instruction into each of those locations, okay? If you need them all empty before you start for whatever reason, you got to manually do that, okay? So Tang, let me know if that answers the question, okay, Tang? And if not, I'll revisit it. And then I'm going to pivot. All right, so Austin asks, okay, Tang's typing. Survey says, I'm waiting for Tang to find out what the survey says. Austin asks a question, which is, you know, after Tang's question, on question number 21. Okay. And then Tang's still waiting for you, man. Okay, Tang's good. Good. Austin says, when it says, so here's what question number 7.21 says. 7.21 goes, assemble the following LC3 assembly language program. What that means is take this program that's given to you and put it into either make a file or copy paste it, type it, you know what I mean, into an LC3 assembler as assembly language. Sorry, I gotta get a haircut. I don't know what this is doing, but it's driving me insane. You're going to drop it into the assembler. You're going to say assemble, and the assembler will convert it into machine language, and then run it, play with it. So you need to assemble it, meaning run the assembler on it. The assembler will make machine code. Once you got machine code, you can run that. Run it. Doesn't say run it, but it would be stupid not to after going through the effort. And then what's it do? Less than 20 words. No more than 20 words. 20 or fewer. Okay? Does that make sense, Austin? I hope. It's a little bit like Hello World. I mean, it's a sense of here's a program, put it in there, run the assembler, and then run the program. And then use that as a way of trying to figure out what it's doing. I mean, you could just look through this and answer that question without using an assembler, but I don't want you to do that exercise here. I want you to actually put it in the assembler and click the button. You see that process live, okay? And then again, as a reminder for those that have joined us later, way earlier in the YouTube live, Josh dropped it's in the chat on Discord. We should also put this in the comments. But his current favorite website for LC3. So that works. Okay. Anybody else? What else you got? 13 minutes. I'm doing the countdown here. Anybody else? What do you got? And then again, for anybody who's joined later, you got to be on all the chat we're doing right now is on Discord on the UVU CS 2810 voice channel and text channel. All the voices coming through YouTube Live and kind of out, but any voice coming in this way, which we haven't really used, is coming through Discord. And then our general chat is happening on Discord. And it literally, I like it. It's a nice app. I literally spent like 3 minutes to get it set up and another 1 minute. The hardest thing I had to do was actually name my server, which was Dr. K's Emporium of Computational Wonder. Okay, Tang. So if you want to store a character into memory, you'd need to use several BLKW. Well, it depends. So if I wanted to store a single character into memory, then I would just need one block, right? If I want to store a bunch of characters into memory, I'm going to need, that's one approach, is several BLKW. So here's the remaining question is, what else? And I just saw your comment, Ramada, but, and I don't know if I can't remember, but I'll go look real quick. I got a number of ways to allocate memory. First of all, I got to have a label in assembly language. I'm going to create a label. In machine language, I don't even need a label. I just decide I'm going to use those, and I just use them, right? Assembler has to know to allocate those, okay? And so Tang, what we're going to do with a character, so block W is 1, and it'll just give me, it'll just allocate however many I want. I could also do dot fill, and I could just do a bunch of dot fills, right? I mean, I can go block W and just say, 20, and boom, I've got 20 words. I could also do dot fill 20 times, Now here, interesting question. Does it matter? I don't think the assembler doesn't care. It's just going to do work. It doesn't really matter. If I say fill, and it's a really good exam question. If I say fill, and I'm like, fill, dot fill, and then I give it a value, which is the value you put into that location. I go, dot fill 0, dot fill 0, dot fill 0. And I just do that 20 times, as opposed to dot block W 20, programmatically the effect is identical, except the dot fills are all initialized to 0. Happy. And the block W, they're not initialized to anything, but I did it with 1 line instead of 20 fills. But the assembler doesn't care, and the program looks the same, except slight advantage to dot fill, dot fill, dot fill. It's just telling the assembler what to do. So back to Tang. That's one approach. The other thing you can do is you can do the dot string Z, page 182, I think, for these assembler. Yeah, dot string Z. Let's say that I want to see dot string Z. Dot string Z tells the assembler to initialize a sequence of n+1 memory locations, and the argument is a sequence of n characters inside double, So you get this thing right here. Here's string Z, if you can see that, right? Dot string Z, hello world, right? Well, I could just do dot string Z and just put a bunch of blanks. I mean, you know what I'm saying? You can use dot string Z. It's going to allocate space, and it's going to initialize it with a bunch of characters. And again, it's another way of just allocating space. Having created, like hello dot string Z, and it says hello world, nothing stops me from overwriting it or using it for whatever I want. It's just memory. Okay. I think I've probably beaten that to death. Let me go back to, and then Tang, let me know if that helps you with what you're talking about. Ramada, I'm just looking to see if we dealt with 7. Oh, no, we did not. We did not do 7.1, Ramada. Okay. Oh, thank you, Brinn. This is looking at the comments. So, all right, thanks, Tang. Looks like you got it. And then, yeah, Brinn, if we can, again, it'd be nice to say, here's the part where Dr. K starts talking, here to hear the discussion of 7.2. I don't know how precise to be about that, but anything's going to be helpful for people, to kind of just get to specific stuff. Okay, Ramada, I got 8 minutes, so let's hit this thing. She asked about 7.1. Let me read it to you. It's right here. 7.1. An assembly language program contains the following 2 instructions. And here's what it does. It has a label, and so you'll have to kind of look on maybe to, and then you can rewatch this part. It's got a label called place. It then goes dot fill and goes X45A7, okay? Again, if you look at that right there. Now what that does is it just designates, what it does, it takes one word of memory. In that word, it puts that value, and then the assembler just remembers that we wanted to call that place, so that later on in the program, if I talk about place, you know what memory location I'm talking about. Okay? Then over here I go load I R3 place. So this one's not super complex. You can finish it in the remaining 7 minutes. Ramada, I think we can get it. Okay. LDI R3 and place. Okay? So what the question really is asking you, do you understand the LDI instruction? That is really what it's asking you. Okay? So we go. Sorry, I'm just looking in the appendices, and I'm back in the 500s. There is, all right, I'm going into these pages, and that's the one I care about right there, LDI. I can't see it, right? This is the one right there. It takes, LDI wants a destination register and a label, okay, in assembly language. It wants a label. We had this thing called place, and we stuck the value in that spot, okay? Here's what it does. And then that's the, there's the way it's encoded right there. That's the opcode. Destination register is these 3 bits. The rest is PC offset 9, okay? Now, going back to what the problem asked, just remember that down in the machine, this is why I don't want to short the machine language. If you don't understand the machine language, you can't understand this instruction fully, okay? Because in the machine language, there's a value down there, which is a PC offset 9, which means that this place has to be close by. Now, it is, because it's just sitting there right in front of it. It's the memory location right in front of it. Then comes this load I. Okay, now I'm just going to leave it here so I can read it. But, okay, actually, I want to bring it to you because I want you to understand this while we're looking at it, okay? So what I'm doing here, and this is kind of notation, all right? I'm going to go from inside out. PC offset 9. I'm going to take this value. Now, remember, in the machine language, we've got to stuff that value ourselves. The assembler is going to create this value, okay? I take that PC offset value, I sign extend it to 16 bits. I add that to the PC. That's what you do with a PC offset 9. You take those 9 bits, you sign extend it, you add that to the program counter. Now here's the part where load I, the load indirect, is tricky and becomes confusing. What I do is I take that value, this notation right there, the mem and then brackets, that says that everything in this bracket, you treat it like a memory address, okay? So I go to memory in that location. I grab that value. So this mem brackets, at that location, there's a value. I pull that value out. That's not my answer. That's another address. And then this mem says treat all that like an address. It's a level of indirection. So this PC offset tells me where to go to find the first address. I go to that location in memory. At that location, I pull another value out of that location, and that's the one I shove into the register. Okay? Give me some love if that's making sense, or what I'm telling you makes some sense. So what they're asking, the question then asks, I'm just looking right here. The assembler puts the translated version of the LDI instruction that follows into location 3025, okay? So this load I instruction right here is in location 3025. After the assembly is complete, what is in location 3025? Okay, let me read that again. The assembler puts the translated version of that instruction that follows into location 3025. So what it's really asking you is to take this and assemble it. What is this going to say? Okay, so I mean, I gave you a little bit extra information about how LDI works, and I think that's valuable. Okay, then you got to go back to right here. What it wants, the assembler format, it says assembler format. That's the way it looks in assembly language. This is how it gets encoded, okay? Then what happens is, where are we at? An address is computed by sign extending blah, blah, blah. Let me see. What is stored in memory at this address is the address of the data to be loaded into DR. So anyway, what it's asking you to do, and I'm afraid I'm wrapping myself around my axle because I'm supposed to stop in a minute. But the burning question is what goes right, what do you put right there, okay? And notice that if you go all the way back to this page, notice that LDI and LD look exactly the same. So you're like, what? They look exactly the same. And that's right. And they do get assembled in identical fashion. The difference is that the LDI instruction behaves differently. Well, they behave different from each other, okay? So that in the LD, I go to the PC offset, I go to that spot, that's my value. In LDI, I do the same thing, except when I go to that spot, that's an address, I go to that spot, okay? Is this making sense, Ramada? Got it? Okay, so to wrap that thing up, what I'm gonna do here is just go LDI which is going to be 1010. Destination register, which is 110. That's R3. And then what's next is the PC offset 9. Well, when this is running, I don't know if you can see this. When this is running, the program is right here right after it. So what's that location? What's the PC offset? It's going to be -1, -2. So the PC offset has to be, so what this is going to say is, whatever that opcode was, 110, and then it's going to be the number that equals -2. That's what's going to be at location 3025. Okay. 1001. So that's it. If this is helpful, we can do this again. We can do this regularly. I mean, it's all about, this is help session. This is like extra special TA time to kind of help walk through, you know, these specific things. So we're definitely out of time. I'm gonna stop the broadcast right now. The link's out there. When it's out there, I'll double check to make sure that this is posted somewhere on Canvas. And then, I'm glad it was helpful for those of you here. I mean, it wasn't like a big crowd. Some are going to look at it later, but it's still better. I mean, time-wise, it's still more efficient and scales better to even help, you know, 10 of you tonight instead of each of you individually in my office, or maybe no, because it's just too difficult. So, plus the others. So, all right, guys. Thanks for helping me with the experiment. We'll get better at this, but we'll hopefully we do this again. We can do it again next week. We can do it for the exam, you know, potentially. So, all right, later.